Hello everyone, my name is Brian Scholes, an event manager with OzIMM, and I'll be facilitating today's webinar, Designing Cost-Effective and High Value Add Projects. I would like to thank you for attending the live webinar today and those who are viewing the recording. Just a few housekeeping items before we get started. Everyone is on mute today to avoid presenter distraction and noise feedback. We will have time for your questions at the end of the presentation. Should you want to ask any questions, you can type them into the question box available to you on your side panel. A copy of the webinar will be sent via email to everyone who is registered in the next few weeks. We'll also have a quick exit survey when you leave the webinar. I'd now like to introduce today's presenters from Ausenco. We have Ron Douglas, Executive Vice President, Office of the CEO. Ron has 35+ years experience in project delivery and resource sector management globally. Ron's extensive experience on various owners' teams for major projects supports Ausenco's approach and processes and the delivery of successful projects for Ausenco's clients, people, the local communities, and business. We also have David Bainbrigge, APAC Africa Engineering Director. David's experience in the resource sector includes all phases of project development across Australia, Asia, South America, and Eastern Europe, predominantly focused on copper, gold, mineral sands, and coal. Finally, Matt Pyle, Global Director, Technical Solutions. Matt has extensive experience in the design, operation, and optimization of minerals, base metal, and precious metal processing plants. His experience spans all project stages from test work management, concept level designs, and due diligence through to detailed design, commissioning, operations, and optimization. Over to you, Matt.
Thanks, Brian. Good morning, everyone, and thanks for joining us. Today, we're going to continue our webinar talking about the changing landscape of minerals processing projects. And as you know, for those that have joined us before, we're talking about the whole project, basically from exploration through to product. And we're looking at a project life cycle from study through to design, construction, operation, and optimization. Please enter your questions as we go, and we'd be more than happy to discuss them at the end with the free time left over. So this is the third webinar in our series of 6 webinars, and this webinar focuses specifically on designing low cost and high value add projects. So the focus is on design. The previous webinars, you can go back and look at those from the OzIMM platform, where we provide an overview and introduction, and our last webinar was talking about how to set up studies for success. With that, the topics for today, Ron will be talking about the changing approach to design and the impact on project costs. Dave Bainbrigge will be talking about designing for cost-effective projects, and I'll talk about how design, schedules, and vendor data affect outcomes. Without further ado, I'll pass to Ron Douglas.
Thank you, Matt, and welcome everyone. And I guess I was probably approached to do this because I'm old and I've seen a lot of changes in design, and thus I was probably the most appropriate person to talk about it. And I see an image jump up here on the screen, and I'd like to point out that's our Mina Justa project in Peru at this moment in time, and we're just about to start commissioning that. So 3,500 people on site. But anyway, let me get to the talk itself. It appears to me that engineering design, our profession, or at least in mining and metals, is static or declining when measured in metrics of capital performance, schedule compliance, and plant performance. And what I mean by that, I compare ourselves to the manufacturing sector, which demonstrates continual improvement with lower costs, improved performance, either for cars or widgets. While we in projects, we find new ways, or even repeat the old ways of getting repeating outcomes that are not planned and destroying shareholder value. There's a lot of published literature on this, Edward Miro from IPL and others, and in fact I can cite quite a number of projects where the industry has failed to achieve the business case upon which the project was approved, so therefore destroying shareholder value. Now, we forgive ourselves with this outcome by ascribing how complex capital has become. So we develop new tools and processes to manage the complexity and the risk. However, the failure rate sort of stays the same. It has remained unchanged over the 40-odd years of my time in this industry. Today I'm going to discuss the ways that the design has changed and the impact that it has had on capital development. And I'm going to look through the lens of tools in use, in other words, what we use, how we've commoditized the design skills, the contract styles that are now in place, and people and risk. And there's going to be a lot of things being shared. And if I could leave you with one thought for to leave this presentation, it actually is to find an expert and engage them at the right cost. And like all these things, I'm going to use a personal experience. My personal experience where I learned this was actually with my first house and needed to build a fence. Now, I was in Perth, and so a fence in Perth is through a product called Super 6. It's a fibrous cement product. It's corrugated, and you dig a trench, you put it in, you bolt the next one next to it. What could be hard about that? So the client, my wife, subcontracted that task to me, and I found a fellow contractor in my brother. We dug the trench and we started to put in the Super 6, and within 3 panels we had a dog leg. The client immediately sacked her subcontractor, me, and told me to go about my business of engineering. Came home 3 days later, where she had actually contacted an expert, and the fence was this beautiful line of fencing, gate hung. It was just perfection to behold. And I said, so how many people did it take to do that, sweetheart? 1. The difference was he knew what he was doing. We would have ended up with a fence and we would have ended up with a gate, but it would look nothing like the one that was now surrounding my yard. And this is analogous to actually process plants as well. Any engineering company can design a process plant once you have a flow sheet. However, the difference between an expert company and a vanilla company is chalk and cheese. It is extreme. Both will produce gold, copper, iron ore, or whatever, but as you watch the plant, you'll see how material transfers onto conveyors or slurry moves in through pipes into tanks. And the difference will be in one plant, it will be efficient, it will be saving energy, it will be reduced costs. The other, you'll have spillage, the operators will be constantly cleaning up, and there's a significant difference in both cost and outcome, despite the fact they're both producing the metal of design. So, without further ado, and that message to be kept in mind, let's move on to tools in use. Now, when I first commenced, designing actually looked like that image on the left of your screen. There were people on boards who laid out the concrete, the steel, the tankage, the electrical in pen and ink. And if you had to change it, you had to get a scalpel out, or he or she had to get the scalpel out to actually take their work apart. Needless to say, engineers were pretty considered before they went down to have that discussion with the designer. Drawings were then issued, photocopied through a big producer in a bundle, given to the construction team, and off they went to somewhere in the world to build a plant. Now, change was always slow. It was either via mail or when we got really modern, it was via a fax machine, which is probably alien to a lot of people on this call. However, these plants got built, they produced metal, copper, gold, whatever the product was, and in fact they built companies, whether that was Grasberg for Freeport or Obuasi for Ashanti or Escondida for BHP Copper. These were significant ventures that were successfully executed by an individual drawing it on a piece of paper. Now, I've observed the transition to 2D and then to 3D. The design costs have increased. Change is constant now. And why? Because we can. We just open our computer and we can instantly change what's there. However, the construction team still needs the drawings, and the interface issues still plague the construction phase. So we're seeing the same issues and impacts occurring that occurred 40 years ago. It's just now happening in a 3D and electronic environment. Now, David and Matt will talk about the specific matters in the design phase that actually contribute to this. However, the fundamental premise is that humans will be humans. To that fate, the communication between the disciplines is important. How vendor data appears is important, and both will be dealt with by my co-presenters. And we need to design what is fit for purpose, as every plant is different and every ore body is different. So we move on to commoditization of design, and this is, and what I mean by that is that it's sort of analogous to my fence story, knowing that projects have got more complex. However, they don't need to be complicated. Now, the industry and clients have a tendency to ascribe the same skills and competence to each firm of engineers, be they 10 people or 10,000 people, and select on price. It's the quality aspect of the engineering teams is actually dissolved to lesser value. This is now exacerbated by having the procurement department select design companies. So it's like buying a commodity, a ton of steel or a ton of design. It's the same thing to a procurement group. This is, of course, nonsense, and we need to bring back the professionalism between the clients and the contractors. We haven't helped ourselves with the focus on the design tools. So there's a migration between the industries. So oil and gas or paper or mining and metals, if you're a designer in one of these, you can transition between the disciplines now. And this has a tendency to homogenize the designs and the standards rather than being explicit for the commodity. And in fact, at a recent copper project that we executed, the client's representative had us do flange control. Now that's flange control is pretty important on an oil and gas facility where the processed fluid is highly dangerous and could result in an outcome detrimental to all. However, if the outcome is potentially some water or slurry dripping on a hard hat, the imposition of that particular cost is hardly relevant. So we are now commoditizing our design. We're treating engineers like a commodity that you just buy by the dollar and not ascribing the skills. And accordingly, the industry is acting the same way. And so the participants are actually, whilst we're doing more complex plants over multiple years, they're becoming more focused on just one element of that, and we're having lesser outcomes. So let's look to contract styles now. This is how we engage our engineers to do the design. There used to be professionalism between the client and the contractor. However, with this commoditization, the relationship has become more adversarial. So the clients look to contract styles to provide leverage over the contractor, the engineer, because the inference is that we can't be trusted anymore. And so designs are now procured through a fixed price or some form of mechanism that transfers risk to the contractor. So now, and the attached image is, and don't pay too much attention to the percentages because I put this together for illustrative purposes. No longer is the engineer worried about doing the best job. He's worried about making a profit and getting stuff out the door to make sure that he's not going to erode his fixed costs or his profit. So what happens is the client focuses on, and I'll just use the EPCM there, 15% of a project, save 10% of that, so that's 1.5% of the job. So and then engage the engineer on a fixed price. So he saved himself 1.5% of the project. Now that engineer who is just trying to get stuff out the door now has actually got control over all the bulk materials and associated labor that goes with it, which is 67% of the job. So a 10% increase in 67% is 6.7% increase in the price of it. So a 10% reduction in the EPCM could potentially result in a significant increase in the CapEx. The focus needs to be on the absolute and not on the elements. So the risk transfers immediately back to the client by the intention of transferring risk to the contractor, the engineer. Okay, let's move to people. And I've grabbed this here, and I'm going to talk about bias and introduce into projects. Now, that bias can be from the engineer, or it can be from the client or the sponsor. I'm going to say it is about how people behave, and these two pictures here illustrate this perfectly. These are two gold projects that were identical in most respects: the ore type and grade, the country in which they were developed, and the year that they were developed. So all intent and purposes, they should have been the same. However, if you look at the outcomes down on the metrics, plant 1 with concrete at 2,435 cubic meters and plant 2 at 6,870, structural steel similarly, and the footprint similarly, ending with a cost, one being 43% the value of the other, the capex, which has, in this case, because capex is at the start of an investment, immediately falls directly to the present value of the investment. Now, the difference is that one was driven by preferential engineering, while the other was driven by price. We just want to have something that produces, in this place, gold, to the best of its ability for the lowest capital cost. Now, often these decisions are made within teams, project teams or corporate teams, where bias is being introduced by, I don't like that pump, or I don't like those mills, or I don't like whatever, because of an experience that has occurred at a previous project. Now, this project is their experience in, because often they are linear in how they do things. Yet an engineering company will build 100 of these process plants. So it knows that sometimes manufacturing failure occurs, and knows that the next job, the pump will be fine, the mill will be fine. And it actually looks at the appropriate risk selection for the outcome required by the client. However, we're back to that lack of trust. In the same with contract styles, often there is a trust issue around why is that selection being pushed. Which takes us on to risk management. Now, you'll have to excuse the drawing because risk management is actually a topic on its own, so I'm not going to spend too much time here. But what I want to say, as we source minerals from deeper and more complex ore bodies, there's enough risk without introducing more through the design process, the purpose of this talk. So if you select wisely, designers can materially impact the project, either positive or negative. And often it won't become visible until contractors are on site and costs are starting to be incurred. There is no perfect design. So it doesn't matter how many times you open your 3D model and change it, it will never be perfect. And so project development is actually akin to sub-optimizing everything. You cannot have everything perfect. You have to sub-optimize everything for the optimal outcome. So this rather tongue-in-cheek image is, as I say, good, fast, or cheap. Pick any two. You can't have three. So projects are complex, however, they don't need to be complicated. Let's simplify the design process and put in place the first building block of a successful outcome. So thank you very much, everyone. Some things to consider, and now I'll hand to David Bainbrigge, who will talk to this in detail. Thank you, David.
Yeah, thanks, Ron. And thanks everyone for joining us today. It's great to be here in the webinar series. Today I'm going to talk about cost-effective design. I'm going to go through a few slides about what it is, why it's important, why is it difficult, and how we can achieve cost-effective design. And then I've got a few examples before I hand over to Matt. So on our first slide here, I'll talk about what is cost-effective design. So coming straight off of Ron's discussion about it's not about perfection, that leads nicely into this discussion here, because cost-effective design is actually not about the design itself. and it's not about being the best, and it's not about perfection. It's really trying to achieve the desired outcome from the design for a cost. And in reality, you may spend more money, you may spend more time, you may use more materials, you may use more resources, because ultimately in the design phase, it's not about being cheap. You know, echoing Ron's sentiment around where you're trying to save money, this may be a false economy. Actually, cost-effective design is a cyclical exercise. You do strive originally to get more with less. That's good engineering 101. However, really, to get a cost-effective design, it's a cyclical event. You go and you look at getting the most out of what you're trying to do. Then you think about the end in mind. You have your life cycle costs of the ultimate project. You need to consider time as a very valuable commodity, and then you need to consider sustainability. And so really, for cost-effective design, it's really not about design at all. It's about that cycle and coming up with a design for a cost that really lends itself to overall project success. So in talking about why it's important, so the reason the cost-effective design is important is that it protects the asset value. You know, ultimately, when you go to start a project, there's only so much value in the ground. There's only so many grams of gold. There's only so many tons of copper. So in terms of protecting the asset value, you want to get that value out of the ground for the minimum amount of money. So in the design phase, it also maximizes the opportunity for success. A great design doesn't lend itself to being successful, but it instills the opportunity to be successful. And Matt's going to talk about some of the challenges later on about a good design doesn't necessarily lead to a great project, but it's the time when you can put the most opportunity into the project for it to be successful. As an industry, we are responsible and accountable. I think the world we're in right now, we owe it to our greater community to be responsible and accountable for the outcomes, to use the resources most sustainably. And as everyone knows, the environmental, sustainable and governance, the ESG industry is well and booming, and it's becoming a focus now. So as engineers, it's really that we owe society to do the best in this space. We want the project to be sustainable. We want to do more with less, whether it's people, whether it's the environment, whether it's resources. Doing this lends itself to having a safe project. Ron spoke about how ore bodies are more complex. The ores are deeper. All of the easy sites have been mined long ago. So in terms of assessing the ore body for how much capex it can actually withstand, it's no good coming up with the best project in the world that the ore body can't sustain, which leads to owners only having a limited capital. So there's a philosophical idea that an ore body may be able to support a certain capex, but owners don't have unlimited capex to spend. So obviously that's something to consider during the design. And there's a simple metric, and it's not true for everything, but generally if you can spend half the amount of money to get that ore out of the ground, then you're going to double the NPV of the project. Now, that doesn't apply to large projects. There are other metrics, but as a general rule, especially when playing in the smaller project scope, if you can get a project up for half the amount of value, you've basically doubled the value of the project. So why is this so hard? Well, it's a holistic sort of thing to do. And by nature, humans aren't holistic nor iterative. We like to get something done, we head out for an objective and we get it done and it's done. But actually, as we talked about on the first slide, it's actually a holistic, iterative process. You have to reconsider the outcomes every time. And as Ron spoke about, there are very strong competing needs on a project. And at the beginning, there are various people who will have an idea about what good looks like. So in terms of Ron's unicorn project, if you head out for the unicorn project, you're most likely going to be unsuccessful because, as Ron said, generally you can have a good and fast, you can have a cheap and good or fast and cheap, but it's very, very difficult to find that unicorn project. And Ron will attest, if you look at the history, there aren't that many unicorn projects out there and there probably aren't many coming. So it's about the competing needs that people think every project's going to have the best of all, and it never really is that way. And that brings us to the definition of value. It's very contextual. And once you've defined what value means, it starts to lend itself to which of these three metrics are the important part for your project. And the recognition of cost. Cost often comes back to dollars, but there are other costs that need to be considered. There's human costs, there's environmental costs, sustainability, governance, community, license to operate. There's so many other costs that need to be considered, and unless you're aware of them, you can become focused on dollars, and that might not lead to the project that you want. And lastly, it's siloed thinking. It's very easy for someone, say in my space, strong in the engineering space, to head out for the best engineering project. And Ron will tell you that that's never going to lead to a great project. So it's important that it's a cycle, that you're really aimed on getting a project at the end, a really high quality project, not a great engineering design, not just fast construction. It's about a holistic approach. And I've got a statement there at the bottom, which I think most people in this webinar will be familiar with, that vanilla engineering. A good engineer can do for $1 what any fool can do for 2. And remembering that is how we add value to the projects. So given that we accept it's hard, how do we go about beating that hard? So these are the 4 things that really lend themselves to having a great design. Purpose. At the beginning of the project, defining what value looks like requires context, and defining for the project team what good looks like. Understanding with clarity and simplicity. If you can't explain something simply, perhaps you've not defined it well enough. So defining the purpose and then being able to explain it with clarity and simplicity. And remembering that the purpose may evolve. Things change, commodity prices change, the environment changes, as we've seen over the last year, and also owners might change, objectives might change. So making sure that we check throughout the overall process that the evolution of projects can be a number of years, and the purpose may change. So always checking yourself against that purpose is important. Building a culture. It's hard to define what's good, and it's very hard to get good from a set of rules. So often it's about the culture, and having a culture of finding a better way, accepting that there are new ideas and technologies, and understanding that improvements can be incremental and innovation can be incremental. So if you're copying something that's been done before, it's important to recognize that it may not be the best way, but also balancing that approach, because finding the best, the most perfect way of doing things is not actually necessarily adding value. And creating a smart team, not just smart people. We need smart people, that's definite, but you really need good management, because smart people, especially in the engineering space, really want to do things better. And there's a point when that's not really what you want for the design. So having a smart team that understands where you have to get to make the project successful. And then you need to underpin it all by processes. Simple, clear, and robust processes, not chapter and verse, but making them accessible so that people know where to get them. And from an understanding perspective, they're accessible too. Easy to understand, easy to follow, and then making sure that someone in the group is accountable for them being followed. And if you do these things, you're part way on the way to being successful in cost-effective engineering. So next I'd like to talk about is a couple of case studies. So this case study here was a project that was done in Peru. It's really the classical cost-effective design. In this case, there was $800 million added to the MPV of the project. The 50% smaller footprint, 35% reduction in concrete per megawatt of installed power. We installed 60% more power in the smaller footprint. And the ultimate project processed 57% more ore than the DFS design. Now, I've also got another point on here which is very important, because remember I talked about cost. So here we did 7.7 million man-hours LTI free, and that speaks to how safety is a very important factor. The cost, the human cost, can't be discounted. But this is a very classic, if someone talks about cost-effective design, they're going to talk about making things smaller, making things more compact, and this is something that we do often. On the next case study, I'll just take you through a slightly different take on it. So this is the case study from Australia. It's a very recent copper project. And you can see there we've got 2 layouts side by side, and there's a 50% footprint compression, which is what we talked about last time. But the other 2 elements here that I wanted to talk about was that there's a 43% reduction in trafficable distance. Now you can see in one layout there's roads, there's a long distance between things. And Ron will tell you that if you don't put something nearby, no one's ever going to go look at it. So that's a human factor. If you put something miles away, people aren't going to spend the time to go and look at them. So there's the time element too. So we reduce the trafficable distance so that it's easy to get to things. And then there's the processing distance. So there's a 50% reduction in the distance from the mills to the thickener, and you can see that the process routes themselves are much smaller. Now, why is that important? Well, on the next slide, you can see that by reducing the overall distance that you need to send material, the project uses 30% less power. Now, that's important because that's not about capital cost. That's about lifetime costs. That's about making the project robust and sustainable. Now, in terms of reducing the footprint and reducing the quantities, the other benefit to that is an environmental sustainability benefit. You can see here, by reducing nearly 500 tons of steel, you never have to manufacture that steel. And by not having to manufacture it, you save a lot of energy and you save a lot of carbon dioxide. It's the same with the concrete. You save nearly 1,000 cubic meters of concrete, and there's a lot of production energy and a lot of CO2 emissions that never get expended. And you don't get those benefits back because once they're spent, they're spent. So every time you can reduce something on the way to achieving a fantastic project, it's got these everlasting benefits. So I have another example. This is the third and last example before I hand over to Matt. Now, I've brought this one in. It's an example from Canada. And, you know, if for those who aren't sitting in Australia watching the webinar, you know, Canada, the environment's very different from Australia. And this project was built in a very cold part of Canada, and it was also built during winter. So the traditional way of making a cost optimized design is to reduce the footprint, which is what was done here, 17% reduction in concrete, a 14% reduction in pipe work, and a 15% reduction. However, in this case, more is actually less. The iterative process I talked about means that once you've done that, you still need to go back through the cycle. And in this case, we intentionally increase the footprint of this site because we determined that the benefit of making it slightly larger had huge benefits in the construction phase. And in this case, you can see we've opened up a space here next to the leach tanks. And what that meant was that for this project, there was no scaffolding needed. Now, that might not suit every project, but here in a very cold climate, it meant less hours on site. It meant people not exposed to the element, and it drastically increased the safety of our construction in this space. So remembering that cost-effective design is a cycle, it means that sometimes intentionally adding a bit back in can be very, very beneficial. Now, once you've done all those things, I'm going to pass over to Matt, because even once you've done all these things, there are still a lot of challenges in getting a project done, and he's going to talk to us about how once you've put this in place, the engineering schedule itself can largely impact the success of your project. So I'll hand over to Matt. Thanks very much.
Thanks, Dave, and thanks, Ron, for your very informative sections there. And like Dave said, I'll talk a bit about not so much the scope, but the way in which you get the outcomes, and with a particular focus on schedule and managing information. So I just thought I'd start by talking about a current project I'm working on. And we're working through, and actually construction starting on this project next week. But to get to this point, the original scope was pretty vague. There was a lot of iterative changes around the client, who can be difficult from time to time. There's been slow decisions on a few key issues, and I guess some backwards and forwards on that, and really probably not too much schedule pressure. The project is actually a house we're trying to build next week, and actually when we started the process, I said to my wife, who you might have picked up was the client in this case, I said, we'll have this whole thing designed before you pick the colors, and needless to say, the house might actually look like this when it's done. So the serious point in that is, I mean, I guess I could live with a slow schedule for building a house where it's a liability and not an asset, but for projects where you're trying to return value from ore in the ground, schedule becomes an absolute priority, and that's, I guess, what I want to focus on today. Teasing a particular issue out of the schedule of projects is vendor data, which really is to say that we are reliant on information that comes from parties supplying equipment, whether they be subcontractors or subconsultants or whatever the case might be. There is a wide range of information that an engineer needs to pull together to be able to bring a design together and actually enable it to be constructed on time. So I'll talk a bit about why vendor data and schedules are important, And then I'll talk about 3 focus areas to improve the outcomes, which are the project strategy, the commercial approach, and the technical interactions between people on the project. So why is vendor data and schedules important? Well, projects must ramp up quickly and they must work. And I'll give a couple of examples of what happens when they don't in the next slide. But this slide is talking to the typical project cash flow on the left-hand side here. And we're talking about, spending capital in the first few years before the project goes into production. There's potential overspend on capital, which can happen with bad engineering or schedule delays. On top of that, you can see if the project fails to ramp up quickly, or if there's any sort of delays in this critical first period of the project, it impacts the bottom line significantly. So the light blue or color here is showing a project that's aligning with the wealth plan and the financial modeling. Projects that don't or that have some sort of delay will see reduced return or maybe a longer return on capital. And projects that have design issues and then that translates to performance issues, they can really be impacted significantly. So to provide a couple of examples around the importance of ramping up quickly, and really there I'm talking about impacts on design affecting the schedule and the start date of production. I've got two cases. One is a large copper concentrator and the other is a small gold plant. The large copper concentrator is nominally a 25 million tonne per annum plant, and the small gold circuit is a 2 million tonne per annum gold circuit. And I've put some parameters in there, but these are just, I'm sort of just throwing standard numbers at the board to just give you an impact of how important it is. And the point of this is that if a large copper concentrator had an extended ramp up by 6 months or a delay to the schedule by 6 months, you can lose 25% of the value of that project. On top of that, if you consider that the plant might only achieve 90% of its design throughput, as in has some constraints in the circuit or some poor engineering, then your value can drop to 40% of your original total. So you can really undermine a project fundamentally by getting it wrong, taking too long and getting the wrong outcome. And there's a similar story that for gold. Obviously, gold price is pretty high at the moment. Copper's not too bad, so I've used sort of recent prices. But in a low price market, this is accentuated. And I guess just to explain the reason why I'm talking about vendor data here, the reason is because it's one of the biggest opportunities to bring designs forward and shorten that design schedule. Here I'm showing on the right-hand side the delays that we've observed on 2 projects. One is a small EPC. They're both copper concentrators. One is a small EPC in Australia, and the other is a large EPCM out of South America. And the bars are showing a histogram of the time that certified vendor data was late. You can see for the large EPCM, most packages are 24 to 28 weeks late on average from the original forecasts. So not helping that was the fact that the initial vendor submissions, as in the first round of vendor data, was on average 5 weeks later than contracted. And then many of those documents had on average 5 vendor review cycles. So that means 5 changes, 5 sign-offs, 5 modifications. So you can see how that cumulatively adds up to extended or lateness of information, and that holds up the design. That means unless you can find an engineering way around it, you may not be able to pour concrete, or you may not be able to put steel up, or you might be double handling or field modifying things where you didn't want to or it didn't make sense to. Now, I guess to contrast that, I'm showing a small EPC project, and I'm showing that although it wasn't perfect, and there were certainly opportunities in this project to actually drive schedule harder than what we did, most of the data was only 4 to 6 weeks late. So again, still not acceptable, but better than what it could be. So in the next few slides, I'll talk about how we can bring that forward and I guess add more money to the value of the project. So like any good project, vendor data and getting the right information at the right time comes down to good project strategy. And that inadvertently comes down to people and the fundamentals of project management, which is that you need a clear scope, you need a good quality team, and you need people working in the right organizational structures with the right responsibilities and accountabilities, and you need to have the right tools and processes and communication methods, and so that everybody's working together. You need to pick the right suppliers for various parcels of scope and level of complexity. You don't want to push suppliers out of their comfort zone. Rarely is there good value or sense in doing that. You need to develop the schedule early, and you need to know what's important and when. You also need to use whatever data you have as early as possible. And the two images I'm showing on the right hand side here, the one on the top is describing the process where you work backwards from the commissioning and early works requirements that are to develop required on-site dates through the construction sequences and durations, looking at the major pieces of equipment and the time that it takes to maybe procure or install them. And that sets the priority for which bits of information are the most important. And they're the ones you go out and try and sort out as soon as possible. The picture on the bottom is showing that a typical vendor data cycle is about 9 weeks, and the steps are shown there. But the key thing is it's really important to use data that's available from previous projects to get a good start on that. No use tendering before you really know what you're tendering. So on this slide, I've presented a table on I guess to contrast two bookends on a commercial approach and what that might mean for supplying information or vendor data into a project. On one end of the scale, I've called it nominally a tier 1 EPCM project, and on the other end of the scale, I've called it a tier 2 to 3, so a mid-tier or junior company with an EPC arrangement. So I'm sort of contrasting, mixing, matching a couple of things here. One is the engagement strategy, and the other one is the size of client and the amount of dabbling, if you want to call it, or complexity in the people and the interfacing. So fundamentally, and this is generalizing, and obviously this doesn't apply to all projects, but we can find that on some large EPCM projects that there's generally low trust between the client, engineer, and vendor, and we see that through organizational structures and bureaucracy and sign-offs and red tape, if you will. On the other end of the spectrum, small EPCs, if we are doing a project at a fixed price, we have a lot of control, and I guess we're able to eliminate to a large extent changes that happen during the course of design that might otherwise detract from the project. That's not to say they don't happen or that certain changes aren't warranted, but it sort of minimizes that change through the process, and only where it's absolutely necessary is to change actually occur. When we look at vendors, an EPCM approach might go to a large number of tenderers, and I've been on projects that have gone out to 9 or so tenders on major bits of equipment. But in reality, that list could have been shortlisted to maybe 2 or 3 if a little bit of pre-work was done. And that's, I guess, a preferred approach for an EPC project. For an EPCM, the engineers are typically asked to define which vendors are technically acceptable, and then someone in a commercial position will accept the cheapest cost. Sometimes the engineers aren't privy to seeing the costs of the packages because there's a perception that it undermines the technical review. Actually, we find that's generally not the case, and giving engineers access to the technical and commercial aspects of the proposals actually enables a better decision to be made, because things aren't generally binary. Life tends to be shades of grey, so that information is useful. In terms of commercial contracting and engineering sign-offs for a large EPCM, the terms can be quite onerous and difficult to agree with suppliers. But if we were doing an EPC or something leaner, we would use the same terms of what has been previously agreed, and we would enable rapid sign-offs by a few people at the right level. We wouldn't be sending documents around for the project manager to approve small amounts of capital. That would typically be delegated. Now, large EPCM projects sometimes try and reduce schedule, and to do that, they might fast track and try and purchase vendor data or tender early. And in doing so, they might actually be tendering on an unclear scope. And by purchasing vendor data early, the vendors don't necessarily engage their sub-suppliers when you purchase vendor data. So the better approach is, or there's a range of better approaches, but partnering with a preferred vendor or sole sourcing, negotiating based on known pricing from a previous project that might be recent, is a good way to do it. Actually buying the equipment is the best way to get vendor data, because then the vendors are committed, or you can commit to buy that equipment with progressive release of holds and funds. And that is a different mechanism that enables them to engage their sub-suppliers. And then around the general approach to engineering, I guess an old style EPCM project might have, particularly during the boom times, vendor packaged a lot of the design. So that would be where maybe a functional specification goes out to the market and the vendors are treated as the experts, which in some cases they very well are, and that they should be. But actually what that does is the interfaces become more of an issue, and the engineering is commoditized, and engineering is not done as well as projects where the engineer is actually taking accountability for the performance of the vendor equipment. That means, in that context, engineers are more interested in the equipment and they're actually making sure the interfaces are better defined. So again, back to Ron's point, a lot of these efforts that we see in projects are about pushing risk to contractors and suppliers, but actually it really just comes all the way back around again. It doesn't actually solve the problem. In terms of how vendors and engineers and clients can interact better, a really good way to get around the bottleneck or constraint of vendor data is to consider flexible design approaches. And really what that means is if you've got, and this is easier for smaller projects than it is for larger projects, but it's on small projects, it's quite reasonable to oversize a pump plinth and then maybe chem-set the bolts down when that pump arrives on site or when that drawing is received late in the design piece. So you don't have to have all the information locked in to actually progress the construction. So you need to look for the ways in which you can do that in the right places. It's important to communicate the right way and tender at the right time. Early tendering on unclear scope is probably counterproductive and costs schedule more than it gains. Face-to-face is obviously the best type of communication, followed by video conferencing, phone and email. And again, the structures that are in a project can change the way that communication is done. And sometimes you find you get the best answers when you just sit down and have a sort of a real technical face-to-face with someone, rather than backwards and forwards on large schedules of, I guess, evaluating various tenders. I guess the last couple of points here are talking about how you collect the information or how you request the information is important. A vendor will not issue a document as fully certified until everything on that document is closed out. But the engineer may only need to know a few things from that drawing. So part of drawing can be certified while the rest is still getting followed up. So having those conversations is important. So the takeaway message for today is that vendor data is a critical path for almost every project. And if it wasn't a critical path and so critical, then I guess I wouldn't have picked this out for this discussion. But the impact of poor vendor data management and the impact on a project schedule can be up to 25% of the project's NPV. And if those issues cause follow-on effects for the plant performance, then you can really destroy a project. And that can happen and has happened recently. There are examples of Australian projects that are now in care and maintenance, and this may have been a factor in that. Having said that, there are opportunities to do manage vendor data and information that feeds into designs much better. A key element here is trust, as well as good project management, vendor engagement, and getting good engineers on board. So that wraps up the topic of the talks today. You heard Ron talk about how the approach to design is changing and what that does for project costs. You heard David talk about what cost-effective design is and isn't. It isn't just a race to the bottom in terms of lowest cost. It's about finding the best value solution for the project. And I spoke about how the reliance on information affects design schedules, which then can ultimately impact the performance of the plan and the return to shareholder wealth. Please load up questions into the box, and I will see what we've got here. So just to kick it off, Dave, there's one here that you might be best to answer. Can you share an example of how you beat the challenges around cost-effective engineering, including culture, for instance, or any other topic?
Yeah, that's a good question actually, and thanks to the person who put that up. It's difficult, but you have to deal with it intentionally. I mean, I'm as guilty as any young engineer when I first started out of heading off down a path of what I thought was the best. And it tends to be associated with buzzwords, you know, oh, today we're doing lean and now we're doing fit for purpose. And as Matt said, a race to the bottom. And, you know, in the 2000s, I'm as guilty as anyone of jumping on a project and knowing what's best. And I'm going to, you know, do better this time and it's going to be cheaper. And that's not the way. And I think when you get on a project, it's really about alignment, and it's taking the time to understand the value of the project and what good looks like. And it's about being thorough and taking the time and getting stakeholders involved. You know, you'd be surprised how often a project can progress significant way through the cycle and a construction person or a commissioning person has never even looked at it. And I think that's the key, is right at the beginning, understanding what the value of the project, what's important, and then continuing to check that. Remember, I discussed that purpose may change, but also it's important that as you onboard new people, as new stakeholders get involved, as the team grows, that you have this pretty clear view and vision of where it's going, and you take the time to make sure those people understand as well. It's too often that we go and have the first solid team get together at the first milestone, and then it's too late. One of the most successful studies I've been associated with recently is that the first team to get together is to sit down and agree what good looks like and spend the time to get that good alignment and write that down and check against it. And I think that's one of the key things about really having a successful project, is finding that alignment and having a bit of unwavering focus on it. So that's my answer to that question. Thanks, Matt.
There's a question here I might flick to yourself, Ron. You started showing the picture of the drawing board, and obviously designing tools have come a fair way since then. Where do you think we'll be in the next 10 years?
Wow, if I knew that, I'd be a very wealthy person. If you just look at the way that 3D is now, you know, you can just craft 3D parts and tools out of different things. We're certainly going to design differently, and we're going to manufacture spares and everything differently. And yeah, I'm amazed at what we do now. The difference, however, is that in the mineral processing industry, there's still large bits of gear, and so it's pretty easy to imagine, you know, small electronics and software and that, but at the end of the day, we take big rocks and turn them into little rocks, and put them into a slurry and, you know, pull 1% of the product out. So I think the advantage, where we'll go in our industry is how we all sort and how we concentrate without removing all that material. So it'll be more about in situ, and so it'll be more about how you mine rather than how you design will be the step changes.
Good one. There's a really interesting question here. I'll read the question out, and then I guess we can decide who it goes to. This question's from Sam. He says, we've seen that equipment supply mergers are tending to monopolize the industry, and that some of them, I guess, are claiming or potentially looking to design the whole process plant, or at least supply everything within it. How is this affecting the way that engineering is being done?
I'll have a first swing at that, then you can follow up. And it is very common. In fact, the large equipment vendors, whether they're FL Schmidt or Udatech, because they have a whole suite of the mills, the crushers, the floats, and so they're essentially selling their product. So they'll put the engineering together in some fashion, and I'll revert back to go and get an expert. Like their primary role in life is manufacturing and designing equipment, getting them to do the layouts. And I say they're usually pretty average, and so you'll usually get what you pay for. So buy the equipment because they're brilliant at that, but you'll always end up with a lesser outcome. Letting them put them together in the way they see fit.
Agreed. Dave, have you got anything you want to add to that?
Yeah, probably, and have to admit I have in a previous life worked for one of those equipment suppliers, but I think what I've seen, and it's a little bit of a shame in some respects, is that there was a real differentiator between equipment suppliers previously, and a little bit of a quest for excellence. If someone only did crushers, then their product knowledge and the life cycle and the development, in my opinion, it had a bit more focus. I think the focus on end-to-end supply for equipment has led to a lot of the large groups having maybe being a little distracted in that space. So even for us, and what Matt said is that, especially with different types of contracting strategies, we sometimes find ourselves looking to more boutique suppliers anyway, because we are looking for specialized products, we are looking for differentiators. So I think there's pros and cons, but really I do sometimes hark back to the previous version of the industry where people really focused on excellence in their particular product, and I think maybe we made faster advances in that space. So you can take that as what it is, but that's how I feel about that.
Thanks, Ron and Dave. There's a question here that is, how are new tools and technologies impacting communications and trust? Which I think is a good question. I might have a first crack at that, and then you guys can chip in on the things I miss. I guess to put that in context, I spoke about it in the talk, but a key part of doing business of any sense, or really any sort of communication for that matter, is just the way you communicate to people. Obviously everybody's doing webinars and face-to-face and sort of Teams meetings and things like that, but they are still flat, and there's really no good way to communicate with body language, and it's much harder to build trust, no doubt. So in some ways, I think we've seen an advancement of phone conversations moving to video conferencing, which is probably a lot of the typical engineers' communication, certainly of 10 years ago, was almost all phone. So that's been an improvement, but we've observed that on difficult conversations, it's much worse to not be in the same room or not be face-to-face. So I think on average, maybe the communication has improved a little, but we still have a way to go. Ron, Dave?
I'll have as I like to opine, I found it interesting that all three of us put trust throughout because it's such an important part of what we do as a business, and in fact our organisation has it that unless we have a relationship with a client that is trustworthy, we loathe to enter into a contract with them, and we certainly won't enter into a fixed price contract with them. And the other thing I've noted is that there's now and this is just an old person talking, there's a proliferation of organisations which now act as a client representative. And it's like the lawyers, in that their whole business model is breaking trust. The client, you cannot trust that contractor. You need to trust me, who will manage that contractor. So there's a whole industry now trying to break trust, while the underpinning basis of how you do business is trust. Otherwise, you can never be successful.
Very good, thanks, Ron. Yeah, we've definitely seen that. So that's a very good point. So that wraps up, we're just over the time now, so that wraps up the webinar for today. Thank you everyone for your attendance, and we look forward to seeing you in the next webinar, which is talking about project execution. Thank you very much.
Perfect.
Thanks.
Thank you, Matt, Ron, and David for taking the time and energy to present today. Yeah, we'll close off the webinar. We hope you found it insightful, and that you will join us for the rest of the series. Thank you once again to Matt, to Ron, and to David. Enjoy the rest of your day, everybody.